Right, in this video I'm just going to quickly go over what to do with your recorded data and kind of how to manipulate it, how to format the table. And then in the next video we'll go over how to graph the raw data and how to identify the relationship, and then how to transform the variable and create your final graph, which includes your transformed information and your uncertainties and error lines and all of that. Okay, so firstly, how to format this data. So what I've done is I've changed the mass to the various numbers that I thought were suitable for my spring. Then I timed 10 time periods for each one, so this is my raw data collected here. The next thing I need to do is to figure out what the average in the time period is. So each one of these is 10 time periods. So what I'm going to do is just average those three by writing in equals average and then drag across the ones that I want to average, and then close the bracket, and then divide by 10 to get a single period. So I'm averaging 10 time periods, then dividing by 10 to get a single period. Okay, and so that averages the first one. I'm then going to go down and average the rest of them as well. Okay. The next thing I want to do is work out what the uncertainty in the time period is. And for that, what I'm going to do is I'm going to subtract the biggest of these three values. Sorry, I'm going to subtract the smallest of these three values from the biggest of these three values, and then divide it by 2, and that gives me half of the range in the values that I collected, which is a kind of rough estimate of how much the time period can vary. Okay, so I'll take the maximum value of those three, and I'll subtract the minimum value of those three, and then close bracket, and then divide by 2. But what I'm really working with here is 10 time periods, and I've divided that by 10. So I also need to divide this whole thing by 10 in order to get the uncertainty in a single time period. Okay, and then I will complete those. Now I only want the uncertainty to one significant figure. There's a button on Google Sheets that you can use to reduce or increase the decimal places. It's up here. So I'm going to decrease the decimal places for that one, and it does all the rounding for you so you don't make those mistakes. Decrease the decimal places there, and there, and there. Okay. The next thing is I need these to be to the same number of significant figures. So most of these are to 3, and so I will just decrease them to 3, except this one is only to 2, so I'll decrease that one more. Now the number of significant figures, sorry, the number of decimal places matches the number of decimal places in the uncertainty, and the uncertainties are all to one significant figure. Okay, this bit of the raw data is not quite complete, so I need the uncertainty and the mass. And so the uncertainty and the mass, we had hangers that set it correct to 1 gram. So really this should be 20 grams. In fact, I'll just make all of them. They should all be correct if I do that. Yep, because I hung 20 gram masses is set to 0. That means that I can assume that the 0 is correct. And I'm going to be plus or minus 1 gram, just to be safe. So my uncertainty is going to be 0.001 kilograms, and that's true for all of them. I don't know what this error is. Nope. Okay. The next thing that I would like to do is to graph my raw data. To graph my raw data, I only really want to graph the mass on the x-axis. That was my independent variable. The time on the y-axis. So I'll open Logger Pro, and I'll switch back and grab this data. Oops. Sorry about that. I'll grab this data, copy it, and stick it in the X column there. Note that we lose all our significant figures. That's why we want to do this table in either Excel or Google Sheets, because it gives us much better formatting options. So we'll also take the average time period, because that's the other bit of raw data that we want to use. And then we want to rename these to mass. m in kg. Done. And this one here is the average period, capital T, and measured in seconds. Done. Okay, we can see our data all down in this corner here. We don't want it to be down in that corner. We want to be able to see it really clearly. So we'll just click this auto scale graph button and it auto scales it. And we'll change this to 0 so we can see what our 0 value is. We'll change the x-axis also to 0. So now we can kind of see the graph. And if you're familiar with your graphs, in fact, maybe I should give this a title as well. So this is raw data. And it's period versus mass. Okay. If you're familiar with your various maths graphs, you should be able to see that this is a square root relationship, or a y is equal to some constant times square root of x graph, or it looks like a kind of parabola on its side. Definitely doesn't look like a straight line relationship. If we really wanted to be sure, what we could do is test 10 grams, and we should get a point somewhere in this region, but I don't really feel like I need to do that. So I would then say that that's a square root relationship. In order to straighten this graph then, we need to take the square root of whatever we've plotted on the x-axis.